Okay, let's get started. Hello and welcome to our latest webinar of 2021. I hope everyone's air conditioning is working well. This summer has been a hot one so far. I can feel the heat roasting me through the window, but let's get started. My name is Darren Lewis and I'll be the host for today's session. But today my colleague Gilles Dereau will be in the hot seat. Gilles is IFRI's Senior Director of Life Science Solutions, and he will be giving today's presentation on managing complex labeling processes with structured content. Gilles will be discussing how structured content within your labeling can be a powerful tool to expedite your authoring and review life cycles, mitigating risk, and improving your cross-jurisdictional compliance. I know that many of you have already attended some of our webinars, and thank you as always for your continued interest. But before we dive in, we're going to cover our usual housekeeping. During the webinar, all microphones will be muted except for the presenters. If you experience an echo, check that your mic is muted in the WebEx window. The microphone icon should be red and have a cross through it. If the echo persists and you're using a phone for your audio, mute all audio devices on your computer. Gilles has a lot of topics to cover today, but time should still allow for a live question and answer period following our presentation. To participate, if you have a question at any point during the webinar, please type it into the chat area of the WebEx window. To send a chat, click the chat button, then choose host from the dropdown. Then enter your question in the chat message area. If you don't see a chat icon, click the view menu and select show meeting controls option. We'll do our best to answer all the questions that we receive, but if we can't answer any of the questions during the session, we'll contact you directly with a follow-up. That's it for me. Hand things over to Gilles.
Thank you, Darren, and welcome everyone. Well, the health authority continue to develop new requirements and new for labeling submissions, and we are seeing a global move towards using structured content for these submissions. And this is not just for labeling. There are various pilots and initiatives currently underway, like IDMP, PQCMC, and EPI, for example. So we see the pace of adoption of the structured content, like XML, only increasing. And the more it grows, the more opportunity there will be to leverage this machine processable product information to more easily adapt to change, reduce risk, and ensure global compliance through reuse, repurposing, and analysis of the content and data in your label. So this is an overview of what I'd like to go and take you through today. I will start with a quick definition of what structured content is, then how structured content can help in complex document creation with automated population, for example, how content can be reused and repurposed, how specific complex processes can be streamlined, how it helps with a global consistency of the content, and finally, how machines can automate the analysis of the content. I hope you will still have some time to address any question you might have, and you must have asked all throughout the presentation. I will start with just a bit of background information on what structured content is and how it differs from traditional documents. But first of all, a very broad definition of what structured content authoring is. Basically, it's a matter of getting away from the traditional flat documents such as Word or PDF, where the information is usually read from left to right and top to bottom in most languages, and where content is mainly formatted text. With structured content authoring, you are now seeing the document as an ordered set of ranges of text that are nested within each other, a bit like the Russian dolls. And this nesting defines a tree of objects. In XML terms, these objects are called elements, and they carry properties which are usually called attributes. Nowadays, producing a document where the formatting is encoded in XML has become very easy. Microsoft has changed its internal format to an XML format called Office Open XML or OOXML. So our authoring tool, FOL, can simply rely on the underlying OOXML structure from Word to take care of all the word formatting while we manage the more interesting semantically rich pieces. One of the main benefits from using structured content is that structured documents are machine processable. And this is rapidly becoming the main benefit of structured content, because computers are now able to efficiently process documents for a variety of goals. I mean, these goals can range from the increased efficiency of the authoring process itself to the quality of the final document and the downstream processes that use these documents. Because you can machine process structured documents, you can extract information, you can automate the content population, you can repurpose or share fragments, you can help specific business processes such as translation, variance, collaboration, and you can automate the content analysis to reach a global alignment across all your documents, not just within labeling, but you could also extend that to other areas such as CMC as well. The benefits of the machine processability here is what we will mainly focus for the rest of this presentation. Another layer of information that can be added to the structured document is metadata, which would you also call properties or property data. Now, these metadata values can be embedded into the document and include any data about the document, such as basically document types, author, permanent ID, etc. So that's the basics that you would have for any document. However, you can also extend this set to store values such as complex product details, company information, or control vocabularies. These pieces of information exist beyond the pure readable content of the document. So details of the product composition, for example, might not be fully described in the text of the document, but it can exist as metadata in the XML format. For example, the textual content might not specify how much of an inactive ingredient your product has, but the metadata can. For editing these type of information, you will need another type of user interface, such as, for example, dialog boxes. And because it uses another interface, it can be also subject to different access rules or access rights than the actual content of the document, if so desired. However, the most important thing here is that this information is still contained within the document, and it moves along as the document is stored, copied, emailed, reviewed, approved, and sent to the authority. Now, I will discuss how structured documents can make complex document creation easy and efficient. And this can be done by either automating the process of moving information from flat files to structured ones, or by connecting with existing content management systems such as RIM, Data Hub, or data warehouses. On this slide here, on the left, we have a regular Word product monograph for Canada, which is unstructured. On the right-hand side, we have a brand new structured document that we have just opened from FOL. And this one here is based on our XML PM template. Now, both of these are in Word. And now if you want to get from your Word PM into the structured XML format, you would simply copy all the content and paste it into a specific section in the blank XML PM that you just created. And then once the paste is done, then you go and click the Add Markup button. FOL is then automatically going to apply the necessary structured information and the sections in the background. And this can be done because the machine can leverage the formatting of the content that you have in Word, such as heading 1 or heading 2, and match them into the section structures and headings that, in this case, Health Canada requires. When the process of converting all the flat information into structured sections is finished, the automation process passes the control back to you, the user. And now all you have is your content in a structured format. Now, since you are left with a structured document in Word, you can still manage all your table, images, footnotes, hyperlinks, all the Word things the same way as you are currently doing it in your unstructured Word product monographs. Now, because structured documents can also be processed by machines, you can get them to interact with other systems such as RIM, data hubs, or data warehouses that you already have in your environment. And this will ensure both consistency of information across your systems, but also within your document set. The first level of such an integration is by sharing control vocabulary. And we are going to be coming to play in multiple ways. First of all, you can implement Thesauri or dictionaries which will allow the users to pick from predefined lists or dictionaries the terms or the code that they might need. Here we have a search dialog for the UNI dictionary, which is the Unique Ingredient Identifier Dictionary implemented by the FDA for the purpose of SPL submissions. These terms can also be used, for example, in keywords and variables that users can insert and reuse all throughout the documents. For example, you can specify your brand name once, and this is going to be consistently used all throughout your document. These values could also be coming from integration with other systems. And dictionaries can also be used for various drop-downs in dialogues or reusable content. For example, on the screen here, the dosage forms, routes of administrations, color, shape, flavor, all these things could be coming from dictionaries. And as the dictionaries or the thesaurus can also be hierarchical, you could define, for example, the list of languages per country. And if you want to integrate with an external data hub, we could directly inherit the full product composition, for example, with the ingredients and their related strength to populate the data elements in an SPL or in a Canada XML PM submission. Now, let's look at reusable content and reusable components. Or if you want to put it in another way, how stored pieces of structured content can be reused in future documents or even excluded from documents based on rules that dictate which elements are supposed to be included or excluded. A key component to globally aligned content is really content reuse. And there is a large variety of approaches to content reuse. First of all, by using business templates, we can ensure that the standard template text is going to be used. This template text is coming directly from the business templates and the health authority and is going to ensure compliance with the regulatory guidelines. Now, as any identified object in a document, for example, a piece of heading, a piece of body text, an entire section, all these pieces of information are going to be externally addressable. They can be seen as reusable components that could be included into another document. And we're going to see that in a minute. Now, finally, you can use a concept of applicability, which within master documents, and you can author documents instances of the same type that are very close. For example, here I have two SMPC documents within one EU submission, and they will only differ because you have variations on the dosage forms and strength, but the bulk of the content should remain the same. Now, in this example, the indication section here is marked as master text because it should be identical across the various strengths. However, we will also have instance text, which is going to be specific to one instance of the document for other sections. In this case here, we just have the strength, so we could use variables, but we could also use something called applicability, which is going to specify that a piece of text only applies to one specific instance of the document. And that's going to be specifically interesting if it extends to full sentences or paragraphs. Specific colors or shape might be different between the tablets that are of related strength, for example. Now, any identified object in a document, for example, as I said, a heading, a piece of body text, a section, all these things could be externally addressed and therefore can be reused as either into another document or into another place in the same document. Shown here, we have an SMPC document here on the right, and we have navigated to and accessed a CCDS document. Now we see here all the sections that we could reuse from the CCDS and apply to the SMPC. And these are the sections in blue with a green check mark here. Now, this can be achieved even without explicitly creating fragments for each of the sections that we want to use, because they can be directly addressed from the outside. Now, sometimes you might want to create an explicit fragment. A good example of this would be if the fragment needs to have its own life cycle. For example, because it needs to be separately or independently approved. So we could decide to create what we call a new fragment that is stored as a separate database object, which is going to have its own existence, and it can be addressed and accessed by other structured documents for reuse. as you create fragments, you might want to choose what you want to include, the current section, the body, just the selection, what you have on your screen. And you might want to also specify how this fragment should behave on update to this document. Should it be an automatic update, just a notification to the user? Do you want to suspend the update, etc.? Now, once a piece of content is reused, we would want to visually identify in the document itself. Here it's identified with a green background. And you would have machine process, in this case, a fragment manager, that would allow you to manage the fragments that are going to be used in the current document. Obviously, you would put this document somewhere into a document management system, and links are going to be established on the document management level to actually know which fragment is dependent on which document, etc. So you have dependency and across your pieces of content. Now, we're going to get into the real meat of the presentation here, and that's how can structure help with your complex labeling processes. Well, the first example is very similar to what we just described. Because we have a structured in a CCDS document, we know the corresponding mapping of all the CCDS sections to the local jurisdiction documents. So we can create the initial version of a local document by deriving it from the CCDS. For example, from the CCDS here, we can create the initial version of the SMPC for Europe. The same mechanism, we could also create the initial version of the PI for Japan. Now, we know that once the initial version is created, it will go and diverge from the CCDS content as you are going through rounds of negotiations with the authorities. But having created the initial version from the CCDS will both help in the initial creations, of course, but it will also establish an explicit link between these pieces of content to help manage deviations on the long run. Variants are another very challenging process. It is sometimes the case that you need to have multiple parallel submissions of a single document that need to exist and be submitted to the health authority. A good example is the case of submitting a version of a document for the purpose to get a new indication or a new dosage forms approved. And this approval process can actually take a while at the health authority level. In the meantime, if a new adverse event is detected, a parallel submission of the same document must occur, starting from the most currently effective text and approved text, and adding the description of the new adverse event. At this point, you will have two versions of the same document that will need to be submitted to the health authority. When the first version is going to be approved, whatever it is, it will now be the official approved text, and it will need to be applied or merged to the other submission. With structured content, the exact location of the changes in the corresponding document is much easier to identify. And this can be done when you rely on a powerful XML compare engine that will identify the changes. And since we have section mapping, all the sections in both documents can be aligned. Now, let's walk through an entire scenario here. So to add your new indication, you will very likely create a variant or a new branch from the approved base content. By creating a variant or a copy, we ensure that this document can continue to undergo its regular updates without hindering the overall process. This variant is then going to be updated with the new indication information, and then it will undergo an internal review and an internal approval process. Once this is internally approved, it is going to be submitted to the health authority for review and approval. Now, at that point, this is where, while you are awaiting the approval for this new indication, a new safety update comes in. This new safety update will be added to the approved label, so you have to go back to the base. Now, so we create a new variant or a second branch from the base, and you see it as variant 2 here. Now, we add the safety information in the variant 2 by editing, and then this file is going to go through its own internal review and then its internal approval. Now, once it is internally approved, it is also going to be submitted to the health authority for review. At this time, you're going to have two parallel submissions to the health authority for the document. Now, eventually, the document for the safety update, let's say, is approved by the health authority, and it's going to make it the new approved base, the new approved version. So we need to replace the old base version with this new approved variant, because it is now the most recent approved text. However, this means that once you do that and you replace the base with what is now the variant 2, it means that the new indication, the variant 1, is now going to be out of date. So we will need to go and say, well, it is now out of date, so we will need to update this what we have sent to the health authority by updating it with the approved safety issues. So we are going to do that by doing a merge between the base document, which is now the document with the safety issues being included, with the variant 1. Now, we can do this merge here because we do have structure and content, and it helps in locating this the document and the changes for each sources of these documents. Now, what we are seeing here is what the result of such a merge operation could look like. The changes from both sources are merged with track change information in different color, depending on the source. Now, the updated variant 1, which is now the merged information, is going to be sent to the health authority, and then they would then verify and approve the new version of that variant 1 document containing the indication section. Once you have all of these approved, this new version, variant 1, needs to be replaced to the base, because it is now the most current, up-to-date, approved content. Now, the overall result of this process is that we have now all the information from both the new indication and the adverse event approved in a time and labor efficient manner. And all of this is possible easily by making use of the structure of the structure document analysis here. The base mapping used in each of the structure sections of the document allow us to align the section and make the merge more efficient and more precise. Another quite complex process is going to be translation management. It is actually a key component to maintain global content alignment. If you are dealing only with US SPL documents, then that might not be needed. But for Canada, Canada is bilingual, and Health Canada is asking you to provide the XML/PM in both languages. If you are going to deal with Europe, then you'll have to deal with 25 languages there. So our system is going to use a translation dashboard to allow the user to manage and monitor the translation process. For that, we are preparing the initial translation work by automating the translation of everything that is coming from the health authority itself, which are the standard headings and the standard text, which are identified in the structural content as semantically regulatory headings or regulatory text. We already have this text in all these languages, so this can be automated. Finally, as the source document evolves and a new version of, well, usually the English text is available, you will need to have some kind of an update function that will identify what needs to be updated in the translation. And for doing that, we are going to modify the source text with track changes as comments into the correct location to update in the translation, and that's going to help the translator. Once again, we can find that location and we can identify it because the document is structured. We're going to see what it means with more graphics here. So let's suppose that you are dealing with Canada here, and we have 2 XML PMs, one in each language, and they were last submitted to Health Canada. Now, changes to the product is going to require the XML PMs to be updated, and the new version is going to be reviewed and approved by Health Canada. Now, the change will be made in one document, in the English version in this case. The Word document is then going to go through an entire life cycle until it's been approved by Health Canada. Once it is Health Authority approved, you will need to go and modify the French version that now is becoming out of date. That automation of the fact that the translation is out of date could just be because you have we know what the English base is, and therefore we see that it's a new version has become HA approved. Now, to update the French translation, an update translation feature in Alice is going to include the English changes as comments into the French document, mapping them to the right section. If we go into the detail and to look at what these updates would appear in these two documents. So on the left, we've got the English document where the changes have been done with track changes, for example. On the right, we have the French document that has the English changes included directly as comments. So we know that this thing here has been modified, and the change that we've got on the severe word here is going to appear, or it's in a blue background, so it might not be quite visible, but it's in a blue background, so people can see what the translator can see the English text and where it's been modified. Also, you could see that any new sections that were added to the English document are included in the French version, accompanied with a comment that is going to indicate that this is a new section in our base. And if a section was removed from the English document, then you would have a comment in the French indicating the removal from the base. Now, this process automates the task of marking up the translated document so that it's ready to be sent to a translator to have the updated section translated. This document could be then exported as a plain Word document. So this document within the system would have structure. If you were to export it, it would need to export as a plain Word document, so structure is removed, and any translator with plain Word could just modify that exported translation. So no Wi-Fi license, for example, is required. The translator is then going to directly enter into the translated text into the specific sections of the document and send it back. That translator could use Word or could use any translator tools that might be out there because it's a plain Word document. Now, when the translated document is imported back into Alice, the system is going to relink the appropriate section structure to the document, making it a structured document again. And this allows to be validated, to have a complete life cycle, and to be submitted to Health Canada as a structured XML PM document. At the end of this process, our French document has been fully translated, and it is automatically linked to the latest version of the English base. So we have helped the full translation mechanism here by using the structure and for example, being able to use this very useful update function that locates where the changes have happened into the English base to apply them into the French translation. Now, ultimately, the entire system is what it's fully meant to produce documents that are going to be published in some format, plain Word, concatenated QRDs for EPAR publishing in Europe, PDF, XML, and made available to the submissions to specific health authorities. Now, once again, by using structured content at the source of this publishing, you can ensure consistency across the various outputs. For example, publishing only the package insert or the med guide, the medication guide, from an approved SPL guarantees that there is no discrepancy between the text that was approved by the health authority and what it is said into these published documents. An XML format can be easily filtered, reformatted, or output to multiple file formats. I mean, that's the core of one of the first reason why XML was created in the first place. Now, we'll turn into another topic that is still complex. It's aligning your content across documents, more specifically, content that must reside in labeling for different jurisdictions. As information becomes available in an XML semantic format, you can do automated comparison because when sections are identified into a document, you know what they are, and you can do interesting things with them. For example, you can map them across documents. And this mapping can be either explicit or implicit. It's going to be explicit when sections carry the same source identifier. And this will happen, for example, when you are dealing with two versions of the same document. The section will carry forward its identifier. So you can map a section with ID 123 in document A to a section with ID 123 in document B. That's also the case when you do a save as function. In both cases, the genealogy of the document, how the document came to existence, is providing the mapping. Explicit mapping can also be done by copy-paste across documents, where the entire section was copied over. The permanent ID of the section is carried over and establishes the mapping. The same thing applies when you decide to explicitly reuse a section from another structured document, or when document B is derived from document A through an automated process, like the one that we talked about, creating the first version of the SMPC from the CCDS. The sections are explicitly reused, and even though they might not be in the same order in the target document. Now, the mapping could also be implicit, and that's when we are comparing two documents that happens to have similarly named sections. For example, even though the two sections have nothing in common in terms of their past or their construction or how they came to be in existence, if both of them have an indication section, you can align these sections and therefore compare them. And this comparison function can therefore be extended to relate content across jurisdictions or to relate tagged information across jurisdictions. The screenshot here shows how a user can choose to compare content or markup, and just select what you want to compare, between the US and Canada. On the Canadian side, the user can choose which language to include in the comparison. In this result here, we have extended the scope of the comparison to include a structured copy of the CCDS. So we've got the CCDS, we've got the US SPL, we've got the Canadian XML PM in French, and the same thing in English here. We also have an extra comment column to allow the users to enter justifications for discrepancies. And we can see how, for example, carcinogenicity only exists in the US SPL, how there is no teratogenic effects all throughout all documents, but excipients, for example, exist in all documents. They exist everywhere, and the content of each of these sections is going to be displayed side by side. Now, this type of automated comparison is only going to be possible because the sections are semantically encoded and therefore can be matched according to their type. Another method of coding information about products is IDMP, which is used in Europe. So a global comparison can be put in place across multiple jurisdictions. For example, we see here part of a coding comparison report across an IDMP-coded CCDS, a US SPL document, an IDMP-coded EMA-SPC. So for information types that could be mapped across jurisdiction, the specific information of each document is going to be displayed and aligned with similar information in the other documents. For example, here the US SPL does not encode any indication information, so that column is left empty. But it is encoded in an IDMP format for both the CCDS and the SMPC. So things could be aligned by category. Here you can align the age category or the intended if it's treatment or analysis, for example, across the documents. As you may know, the US SPL and the Canadian XML PM also include data elements, which are code-specific information about the product, such as route administration, dosage form, composition, etc. And this exists also in part for the Japan PI as well, as Japan is also submitting an XML now. An automated comparison can also be put in place for this coded information. In fact, it's actually easier for a machine to compare than for humans because this information is already stored with codes that are designed for computers. What we see here could be a comparison between two products on the same generic ingredient. So it could be a reference label and a generic product. The brand name and the NDC are going to be different, and therefore here highlighted in pink, but everything else should match and be the same between a generic and the reference label. Now, in this final section, I'm going to show how machine can really help us analyze structured document in ways that would be very slow or difficult to do manually, but are actually mapped quite easily by the computer. Because you have structured content, it could be combined with a semantic analysis engine to go further in the automated analysis, because its engine is going to identify pertinent concepts per section types. Now, in this example here, we have a content analytic report, which is giving a list of adverse concepts, which are present in the various adverse event sections that you could have in a document. Now, these sections could be undesirable effect, it could be overdose, it could be warning and precautions, it could be interactions, it could be pregnancy. There's a variety of sections that are possibly listing adverse events concepts. By aligning up the different jurisdictions and the concept, we can now check how aligned the information is across the documents and the jurisdictions. For example, here we have identified in blue the terms that are appearing inside a local jurisdiction document, but that are not mentioned in the CCDS. And you can see how the US PLR document, for example, and the SMPC are including concept about hepatic failure, which is not present in the CCDS. In yellow, we have identified the other side of things, concepts which are present in the CCDS, but not in the local documents. So the renal failure does appear in the CCDS, but is not mentioned in the US. And I want to bring your attention here to these cells with an orange background, where we have various documents following the similar templates, and they are not consistent either. We happen to have 4 documents that are following the SMPC template, and renal failure appears in 3 of them, but is missing from 1. Now, if you follow the link in these cells, we can get more information about this discrepancy. Now, we know that we are talking about the term renal failure, and we are across SMPC documents. We see that this term is present in the UK, in Ireland, and in India, but it's missing from Singapore. Now, if you click again on the link, we can dig even deeper. At the top here, we know it's the product antibiotics. We are looking for the term renal failure, and we are looking into it's missing from the Singapore document. And we see at the bottom, for each document, where the term appears in each of the local documents, and where what would be the corresponding location in the Singapore document. So in the UK, we have the term renal failure here, and it's not there in the corresponding location inside the Singapore document. Same thing for Ireland, or same thing for India. Now, we're not saying this is wrong or invalid. We just want to bring the attention of the user to these discrepancies here. I mean, there's nothing, it might be perfectly okay. It's just that, from a computer's point of view, this is not consistent. Now, we talked earlier about implicitly mapping sections based on the semantic section names for comparison purposes. If you combine a semantic section name and you apply also some content semantic analytics, you can also establish implicit relationships between documents that are initially unrelated. For example, if 2 sections in separate documents are sharing more than 90 or 95% of their documents, the system might want to warn the user that if you modify the document, the section 1 in jurisdiction X, because it matches section B in jurisdiction Y by 95%, you might want to warn the user that maybe the user should look and update the other section as well. The same way we've done it with content, we could also do it with concepts across documents or across sections. And concept is going to eliminate the idea of the exact terms, but just identify the concept. So, for example, from a prescriber information versus the patient information, we know it's not going to be the same vocabulary, because one is going to be used by a practitioner, and the other one is going to be used by you and me, every patient. So the terms such as pressure across the forehead or migraine, both of these things are going to match the concept of headache. Once again, if you modify the prescriber information, the system might say, well, you know what? Your list of concept here matches exactly the list of concept that you have in the patient information. Therefore, you might want to predict that by changing the prescriber information, the system can say, hey, maybe you want to change the patient information as well. So it's a matter of predicting what should be the changes from the system point of view into another document. So if we're going to be ready to move to Q&A sections, Q&A portion of our session here. So,
yep, so we can pause for a minute there and see what questions we have, or if you have any additional questions, please enter them into the chat area, and we'll review and get back to you shortly. So let's give a minute pause here.
Okay, we've got a question here. What labeling or content might we have within our organization already that can be leveraged in this way? Well, already you have, or you will have soon, obviously, XML content for the SPL in the US, and you will have soon for XML-PM for Canada. So anything that means comparing, or anything of what I've described so far about US documents, either between themselves or between US documents that you have and another one that is available on the DailyMed website, can be used in this way. We also have ourselves structured templates for over 120 jurisdictions around the world. So all these templates, these structured templates, can be used for labeling. We know also that structured content comes in for other areas than just labeling. We also have templates, structured templates, for example, for all the CMC documents. So everything that could go into a structured format can be used for any of these processes and help that I've described so far. Note that if you're watching the recording of this presentation, if you want to send us a question, then you can just contact our support team at IFRI, support@ifri.com, and we can answer any questions that you may have if you are watching the recording.
Okay, no additional questions for us at this time. So I'd like to thank you all for your participation today, and I hope you found this content useful and informative. If you do have any feedbacks about our sessions, please send us an email at contact@ifri.com, or if you'd like to see any future sessions, you can send us some topics or ideas, and we can look at doing those in the future. I think our next WebEx will be about ESG errors for US SPL, and we'll also have a session on the end of year SPL submissions that are required in the US as well for your blanket no change and your establishment registrations. But again, thank you all for your attendance today. I hope you have a great rest of your day.